2.4, bar graphs and line graphs. Turn to page 74 and 75, please. 74 and 75. Go there now. 74 and 75. A bar graph uses vertical or horizontal bars to show comparisons. It compares things. That's what a bar graph does. Okay? A lot of times a bar graph will look like this. They make bars. Does that make sense? That's what a bar graph is they have bars that go up a certain height. Sometimes they have a bar graph that looks like this. Horizontal. Does that make sense? Where the bars go from left to right. Whatever. Bar graph compares by drawing a bar. It's an easy one. It's called a bar graph. I am not I'm not super interested in, or I'm not super crazy about having you guys draw a bunch of graphs because, you need to be able to do it, but it's not like the most important thing. The most important thing about a bar graph is that you're able to read it and understand it, right? That is really what you have to be able to do. When you take a test for like your Terra Nova test, do you have to create a bar graph? Do you have to create one? Do they make you draw one and then they... No. What do they make you do? Read it and understand it. Agreed? So, if here is our... Can you tell me, just by looking at this bar graph, what it's talking about? You need to be able to look at this bar graph and tell me what this bar graph is talking about. I want you all to write down for me in a sentence what this bar graph is talking about right now. What is this? Just looking up there at my chart here, what is this graph talking about? What's it talking about, Caleb?
The amount of calcium
in dairy products. Wow. The amount of calcium in dairy products. Do you agree? I mean, you can just look at this and know what it's talking about. Awesome. When you see these numbers over here, can you tell me what those numbers represent? What do those numbers represent? 300 gallons? 300 acres? 300 tons? 300 milligrams. Now, where do you see that it's milligrams, Jonathan? The bottom, it says mg, right? So it's talking about milligrams. The part I didn't put on here that's important, though, is that 300 milligrams in a cow's udder of milk, in a gallon of milk, in a cup of milk. I didn't write that down. That's important. Do you agree? You want to know how many milligrams it is in a certain amount. These are cups, right? Cups. So in a cup of milk, can you tell me how many milligrams of calcium there is in a cup of milk? Read. 300 milligrams of calcium in 1 cup of milk. How many milligrams of calcium is there in ice cream? Jared? 200. How many milligrams of calcium is there in a cup of yogurt? Jonathan? 250. Does that make sense? Being able to read this, you look at this chart here like this, and you see that this right here is equal to that, this is equal to that, this, right? Oops. That was not true. Right? In the book, it's much more clear. Right? And when you look at an SAT test or a Terra Nova test, it will be very clear. Okay? Look at your book on page 74. Look at the bottom, the question. It says, find the amount of calcium in a cup of milk and a cup of broccoli. We just did a cup of milk. So find for me the amount of calcium in a cup of broccoli. Guesstimation. What would you say that it is, Emily? 95 maybe. I would think it's probably a little lower than that. Maybe like 80, right? 85, something like that. But yeah, it doesn't matter. You're in the neighborhood. They would, if they want an exact answer, they would make it very clear what that's going to be. But it's certainly a little bit less than 100. But it's almost 100. You agree with that? A little less than 100, but it's almost 100. So yeah, like 90, 80, something like that. Good. A line graph is very similar to a bar graph, except instead of creating a bar to show comparisons, they use a line. The line shows changes over time. Changes in data over time. Almost always, when you have a line graph, time is down here, and then the data that you're trying to decipher is up here, is over here. And it always looks, it looks something like that. As time moves on, the data goes up or down or whatever. Okay, this is what a line graph is. When somebody creates a line graph, a lot of times they will have a dot here, 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 and then a dot here. And then you would, like a dot to dot, create the line graph. Does that make sense? I'll show you what I mean. Okay. They use the example temperatures in the day. Temperatures during the day. And so the first one they have an 8 o'clock here, 8 a.m., and then they have a 10 a.m., then they have a noon, then they have a 2 p.m., then they have a 4 p.m., and then they have a 6 p.m. Make sense? And then over here they have temperatures, and one of the things they have is they have 60, 65, 70, 75, 80, 85, etc. Does that make sense? And then so what they do is they show that, okay, so this is the chart. At 8 a.m. it went like this. It was like right there. And then at 10, they looked on their deal and it was right here. And then at 12, it's like right there. And then at 2, it went to here. And then at 4, it's like right there. And then at 6, it was right there. You do your dot to dot as best you can. You would use a ruler if you could. Now, if I was to ask you about this, could you tell me what was the temperature at 2 o'clock? What was the temperature at 2 o'clock? How would you find it? Sladen, what's the temperature at 2 o'clock? Huh? Right, so what is the temperature at 2 o'clock? Well, if here is 80 right here, right, you see how it actually is on the line of 80? So then at 2 o'clock, the temperature was 80. Agreed? At 2 o'clock, the temperature was 80. What was the temperature at 4 o'clock? So you have to look over here and go, okay, it's right here. You go over here. It's a little bit above the line, just barely above the line. So what's the temperature then at 4 o'clock? 75 or maybe 76, right? Since it's a little bit above the line. Do you see on the book there how it's a little bit above the line at 4 o'clock? If it's a little bit above the line at 4 o'clock, it's probably 76. Agreed? Okay. What's the temperature at 10 o'clock, Juna? $70, right? See it? What was the temperature at 8 o'clock, Michael? Yeah, I would say you're right. 62, it's right here. Can you all see that? It's important that you're able to read this more than it's important that you can create it. You should know how to create it, but you absolutely need to be able to read this. Okay. Let's look at this. Look at the bottom of 75. It says which type of data display is the most appropriate to show a comparison of the data at the table on the left. You see the table on the left? Do you see the table on the left where it talks about world's busiest airports? Do you see it? Atlanta has 79 million passengers a year. Chicago has 70 million passengers a year. London has 63 million passengers a year. Tokyo 63. Los Angeles 55. You have to decide which of those four graphs or displays would be the best to show this data. Now, I want you all to write down which one you think would be the best. I want you to write down which one you think would be the best. Let's talk about this. When do we generally use a line graph? A line graph. When do we generally use a line graph? When do we use one of these? When do we use one? Read. Time, right? When the bottom down here is time. Changes over time. That's when you use a line graph. Is this data talking about time at all? Is our data here, the Atlanta, 79 million passengers, is there any time issue there? No. Not a line graph. Frequency table. A frequency table is generally used when you're dealing with similar bits of information that are close together. Does that make sense? If I had a quiz score, and the only options on the quiz were 2, 4, 6, 8, or 10, that would be an excellent time to use a frequency table. Or if the only options are red, blue, green, yellow, that's an excellent time for a frequency table. We're talking about millions of passengers here. Is that a good time to have a frequency table when you're talking about millions of things? Do you really want to put 47,985,825, 47,985,426, 48,000,000? Do you really want to make a frequency table like that? It would take up the state of California. That's how big the paper would have to be to do that. So that's not what we're talking about. Which one should we use then? Is this not comparing from one? Is this not comparing one airport to the other? Is this comparing the airports? Atlanta has 79 million, Chicago 70 million, London 63, Tokyo. Are we comparing those airports? Yes. Since we're comparing the airports, can you see where Tokyo, Chicago, London, right? Atlanta, etc. And all of a sudden you go whoop, 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 whoop. You'd like to be able to see that, right? That's where a bar graph comes in, is when you're comparing things so that people can see, ooh, who's winning, who's doing better, just a visual of what people can see. Does that make sense? Yes? Okay. Look at the example down there at the bottom of 75. Which type of data display is the most appropriate to display the data at the right? You try that one right now. Which one did you write down, Momo? No, a line graph. Why did you choose a line graph? It's time. Do you see it? Week 1, week 2, week 3, week 4. Time is passing. We can see what happens over time. If there's time involved, you're generally going to use a line graph. Does that make sense? I hope so. Let me give you your homework. Notice something different. Don't mess this up. Pay attention.